Hi, I'm Liz Sneddon. Let's have a look at our normal distributions using the graphics calculator. So the first thing we need to know about normal distribution graphs is that the area underneath the curve is equivalent to the probability. So the area is a probability. Also, that the numbers on the axis below, they are our data values. So if I'm talking about weights of cheese, those are the weights. If I was talking about the height of somebody, that's what the numbers represent. So the numbers are our data and the area is a probability. So when I've been given a data value and asked to calculate a probability, this is the first type of problem that we want to solve. So I might be given some particular data value, say here, and I want to know what's the probability of being below that point. Or I could be asked what's the probability of being above this data value here. Or something between two data values. So as soon as I've been given those data values, which I'm going to call x, so these values under here, these are my x's. When I've been given an x value and asked to find the probability, then this is the process that we want to go and use. So let's have a look how it works. So here's an example. Weights of student backpacks are found to be normally distributed with a mean of 3.3 kg. So I'm going to draw my line down the middle there. There's my mean at 3.3 kilos. And it has a standard deviation of 0.3 kilos. Okay, now the values that I've been given, the data values here, I've been told what's the chance that what's the probability a backpack weighs between these two numbers. So 2.7, that's somewhere below the mean, so I'm just going to choose a point here, 2.7, and 3.1 is also below the mean, so let's put that value there, 3.1, and I want the probability of being between those points. So notice how I've shaded that area in. So I need to do this diagram, it's quite important. So this is the probability that I'm trying to find. So let's go to our graphics calculator. And I'm going to go into my statistics mode here. So I'm going to move across and say execute there, move into that mode. Now I want my distributions, so that's my F5 button there. And I want the normal distribution, so that's F1. I'm just calculating the probability, so I want this NCD mode. So that would be F2. And what I need to do now is I need to put in upper and lower values. So if I think about the graph that I've just drawn, this is where this is important. Let me jump back to there. In this graph, we want the probability between 2.7 and 3.1. So the 2.7 value, this is my lower value, and the 3.1, this is my upper value. And I want the probability between those 2 points. So that's what I'm going to put into the calculator. So my lower value is 2.7, my upper value 3.1, my standard deviation was 0.3, and my mean was 3.3. And now I say go and execute that, and then we can see our probability P there on the screen. So it's got P equals 0.22974424. It also gives us the equivalent Z values for those coordinate points. In this case, I just want the probability, 0.2297, and I'm going to write that to 4 decimal places. So, let me jump back into here. So that means the probability there is equal to 0.2294. And that's all I need to do. Let's have a look at a different example. So we've still got our weights of backpacks, and it has that mean at 3.3. So I'm going to put that mean there at 3.3. There's my mean. Then it's got a standard deviation of 0.3 still. And we want to calculate the probability that a backpack weighs more than 3.7 kilos. So I think on my number line, where is 3.7? Well, 3.7 is going to be somewhere above the mean here. So I'm going to say this value there is 3.7, and I want the probability being more than that. So I'm going to colour in, shade in the area above it. So now in terms of my lower and upper values, think about our X values. Think about these weights of these backpacks. As I'm coming along, the first value I come to that I've started shading in is this value of 3.7. So that will be my lower value. Then I need to choose some upper value. Now I don't know exactly what the number is because it just says more than 3.7. So I just want to choose a really, really big number so I know that I'll have everything included. So given the scenario, I'm just going to put an upper of 100. Some big number compared to the data. So that's what we want to do. So I'm going to jump back to my calculator, jump back into this mode, and I'm going to change my lower value there to 3.7 and my upper value, putting in a big value of 100. And now I can execute that, and the probability there, 0.0912. And I'm just going to write that answer to 4DP. So that would give me a probability of 0.0912. So that tells me how big that area there is. There's a 9.12% chance of having a backpack weighing more than 3.7 kilos. Thanks for watching.